Almost everyone knows Newton's third law of motion. It is also called the law of action and reaction. For to every action there is an equal and opposite reaction. But, what Newton's third law really means? What are its internal concepts? Let's review the basics. The third law was written by Newton in his masterwork the Principia. In the section Axioms, or laws of motion, the third law is: to every action there is always opposed an equal reaction. Or the mutual actions of the bodies, upon each other, are always equal and directed to contrary parts. The third law describes the practical conditions for the acceleration of bodies. If a body has to be accelerated in one direction, another body has to be connected to it, and a pair of equal and opposite forces has to be applied, so that they accelerate in opposite directions. Acceleration is the change in velocity of a body, and depends on the applied force and the mass of the body, according to the famous equation. F, the force, equals m, the mass, multiplied by a, the acceleration. This is Newton's second law. To apply a force, however, a force generator is required. This can be an explosion process, a mechanism, or a simple compressed spring. Whatever the process, forces are always produced in pairs, of equal and opposite components. Therefore, to obtain acceleration in practice, using Newton's second law, at least two bodies have to be connected by means of a force generator. Consequently, in any acceleration process, Newton's second law is applied twice, in opposite directions. The force generator, ultimately, transforms a basic form of energy, for instance, chemical, electric, magnetic, nuclear, into kinetic energy, the energy associated with motion. This explains why the acceleration of a body, in one direction, is simultaneous with the acceleration of another body, in the opposite direction. Kinetic energy can also be transferred from one body to another, by means of contact interaction. One example is the impact. The motion of a body is also described in terms of momentum, which is given by its mass, multiplied by its velocity. In this interaction process, a moving body collides with another, stationary body, and transfers kinetic energy, consequently, momentum, to this body at rest. If the masses are equal, the body initially in motion, transfers all its kinetic energy to the other body, and ends at rest.
Right, this is Newton's third law, as usually described. We have action and reaction. However, something is missing here. Oh yes, of course, it is the role of inertia, described by Newton's first law.
Just to remember, the first law states that, when not acted by a force, a body at rest remains at rest, and a moving body moves with uniform speed, in a straight path. To change these conditions, it is necessary to apply a force. A body whose speed changes, from rest, or along a straight path, and a body moving in a curve, are subjected to acceleration. Since this is contrary to their natural tendencies, the bodies resist that change. In other words, all bodies resist acceleration. This resistance is called inertia. Newton described inertia, and made a commentary about how inertia is manifested, when two bodies are in interaction, in the definition 3 of the Book 1, of the Principia. Inertia is defined, by Newton, as a power of resisting, by which every body, as much as in it lies, endeavors to persevere in its present state, whether it be of rest, or of moving uniformly forward in a right line. In the commentary to this definition 3, when describing how inertia is manifested, Newton wrote the following. It is resistance, in so far as the body, for maintaining its present state, withstands the force impressed. It is impulse, in so far as the body, by not easily giving way to the impressed force of another, endeavors to change the state of that other.
I don't want to be accelerated. Then, I will resist under the action of the force.
I don't want either. I also will manifest resistance to acceleration.
This means that, in these equal and opposite acceleration processes, described by Newton's third law, one must take into account the property of inertia of the interacting bodies. This is usually ignored, because it is not clearly stated in the third law. Newton knew it, but the fact that he didn't include the role of inertia in the third law resulted in a misunderstanding of the whole process since his writing. A well-known problem is the centrifugal force concept, and the application of the third law in the curvilinear process. Newton described the role of inertia in the interaction of two bodies subjected to a pair of equal and opposite forces. In the section Definitions of the Principia, when he detailed the concept of inertia. This is what happens in the acceleration processes and is the meaning of Newton's third law. When manifesting inertial resistance to acceleration, each body acts as a support for the acceleration of the other. It is the role of inertia as resistance to acceleration, the factor that maintains the relationship between the force, the mass and the resulting acceleration, as defined by Newton's second law. Without this resistance, the resulting accelerations would be infinite, and the process would be meaningless.
This is the mechanism implied by Newton's third law, completely defined with its two internal concepts. Unfortunately, Newton described these concepts in separated parts of the Principia, which resulted in long-lasting misunderstandings.
The same dynamics also applies to the curvilinear motion.
I don't want to be accelerated. Then, I will manifest resistance to pull you backwards to incurvate your path.
I have the natural tendency to move in a straight path. Therefore, I will resist the effect of any applied force to incurvate my path. Since our inertial tendencies are in conflict, I will manifest my resistance on you, then you will accelerate and I can move in a straight path.
Sorry, this conflicting interaction implies symmetry. Even resisting, I will accelerate, but my resistance will act upon you to force your path to be a curve anyway.
Since a moving body has a tendency to move in a straight path, to change this straight path towards a curve, a force must be applied upon the body. The inertial resistance of the central body acts upon the rotating body as a centripetal force, which causes its path to curve, which is acceleration. The body resists the incurvation and manifests this resistance on the central body. We are calling this resistance centripetal resistance. As a result of this conflict, the inertial tendencies of the two bodies, stated in Newton's first law, are thwarted. In the process, the rotating body transfers kinetic energy to the central body, so that the total energy is conserved. The same can be said of momentum. Therefore, we can identify action and reaction, because the interacting bodies are accelerating in opposite directions. Remember, when a body is moving in a curve, it is being accelerated.
Again, this is Newton's third law, completely defined with its two internal concepts.
This is Newton's third law, described in the rectilinear and curvilinear acceleration processes. Linear acceleration processes usually imply energy transformation, therefore require an appropriate force generator. Linear contact interactions imply direct kinetic energy transfer. Unbalanced curvilinear acceleration processes, as described in this video, imply energy transfer. Therefore, the conflicting inertial resistances of the bodies act upon each other as equal and opposite forces. In the balanced rotational processes, the tangential accelerations imply energy transformation using appropriate force-producing methods. Newton's third law, with its internal components, apply to all acceleration processes. And therefore, we can better understand the complete wording of the third law. In addition to the popular sentence, "To every action, there is always opposed an equal reaction," Newton wrote. The mutual actions of the bodies upon each other are always equal and directed to contrary parts.
Newton's third law contains the other two laws of motion. The first law results in the conclusion that the bodies resist, that is, manifest inertial resistance, to acceleration. The second law states the relation between force, mass and acceleration. And this relation is maintained, due to the property of the mass of the bodies, to resist acceleration, when subjected to a force. The resulting acceleration is finite, because of the inertial resistance of the bodies, that preserves its mathematical relation with the mass and the applied force. Finally, the third law means that the acceleration process requires two connected bodies, subjected to a pair of equal and opposite forces, which implies Newton's second law twice, in opposite directions, plus the property of inertial resistance of the bodies to acceleration, implied by Newton's first law.
Have a good day.